Let's go.
Let's go.
Go faster.
All right. So if you can make this chart for me, first derivative, second derivative, because we're just going to go over notation right now, just so you understand notation. So the first derivative notation, you can either write it as y prime, which we've done it before, f prime of x. This one I don't use a lot. In the other class, Katie doesn't like to write u with a 1, with the prime. She thinks it looks like u to the 1. So I told her, I said, well, just write du dx. And so she likes doing that better, just for her handwriting's sake.
DY/dx?
Yeah, dy dx is just another way to write first derivative. I could have been rewriting dy dx the whole time, but I don't. I write u prime or du dx, whatever.
So du dx is dy/dx
Du dx is the derivative
of u?
of u,
Okay.
okay? D dx of f of x. And then this one you rarely see, but I want you to write it down for those of you who are going to take like higher level math. It's just another way for derivative. I've seen it in a lot of like online math articles and stuff like that, but I rarely see it after that. All right, now second derivative, which really the notation looks like this: y double prime f double prime. This one, this dy dx changes though. It's d squared y over dx squared. And I hate saying squared, but you're taking the second derivative. This one would be d squared over dx squared f of x. And then this one would look like dx squared y. But again, you're not really squaring x. That 2 is telling you to take a second derivative.
Yeah.
Guess what third derivative looks like?
3.
Y triple prime, f triple prime. This one would now be d3y over dx3.
Oh.
This would be d3 dx3, f of x, et cetera, et cetera.
Etc.
Now, fourth, we change it because after 3 prime marks, you don't want to write 4 prime marks, 5 prime marks, 6 prime marks. It just, it's ridiculous. So they did it, they actually write it like this. They write y parenthesis to the 4. Because if they just wrote y to the 4th, that's y to the 4th. So they put y to the parentheses 4. Then they do the same thing here. F to the parenthesis 4x. So again, that means find their fourth derivative. And then obviously these would be with just 4, so I'm not going to write that. Okay, does that make sense to y'all, just the notation wise? Just understand notation. So we're going to take, and it's going to be much easier than what you're doing right now, actually, because I'm not doing any chain rules with these. Thank you, Miss Aceta. Could you imagine? Could you imagine? Crazy lit. That's what it is. So find the first 5 derivatives of f of x equals 2x to the 4th minus 3x squared. Can I fit that all in? Yeah. Find the first 5 derivatives of f of x equals 2x to the 4th minus 3x squared. And you should all know how to find good old first derivative. What would that be?
8x cubed
8x cubed
minus 6x.
minus 6x.
Oh.
Okay? Now, what do you think mathematically you should do to find the second derivative?
Factor.
Make it
You
easy.
should times it by
Good
2.
try to.
Oil. No, you should take instead of 4 times 3.
Yeah, just take the derivative of this guy. What's the derivative of this?
24x 4x is second minus x.
Minus 6.
6. I'm gonna say 6.
Done. Take a wild guess of how you do the third
Do
derivative.
it again.
The third derivative is the derivative of the second. So it's 48x.
How we're doing something.
Again, notice my notation. I really try to be very exact with this. What's the derivative of 48x?
48.
And then what's the fifth derivative? 0. What would the sixth be, by the way?
1. You're undefined.
Negative 0.
Yeah. What's the derivative of 0?
0.
Still 0. Anything after 5 right now is going to be 0, 0, 0. Does that make sense? Very easy. Don't overthink this. This is easy. Okay? There's your first 5 derivatives.
And Luke did like this.
Well, we haven't gotten to the good stuff yet.
Well, I can only come easier.
Exactly. All right, now, how about this question? Find the value of g triple prime of 2 for g of t equal to negative t to the 4th plus 2t cubed plus t plus 4. Find the value of g triple prime 2 for g of t equal to negative t to the 4th plus 2t cubed plus t plus 4. So what do you have to do first? First, find the derivative, then what are you going to do at the end? Plug in 2 into the third one, okay? So that's why you've got to know this notation. So let's find our derivatives, and we're going to have to do it 3 times according to what they have right there. So let's see, negative 4t cubed plus 6t squared plus 1. Right, the derivative of t is 1. This one would be negative 12t squared plus 12t. This one would be negative 24t plus 12. Now that I've gotten that function, now I plug in what? 2. And I would get negative 24 times 2 plus 12, which I believe is negative 48 plus 12, negative 36.
So hard, Luke, so hard.
So,
We're recording.
Really?
oh,
Where's the recording device?
This is it.
Did you record from
Is
that?
it always been able to do this?
Yeah, I've been recording for months, y'all.
No, I meant
Like forever.
No, last year I had my old projector and it made my voice sound like Minnie Mouse, so it wasn't working so well. So this new one is kind of working, although it's broken, the handle right here is broken. All right, so almost done. I got one more problem to you, and then why do we do this is going to be at the end right now. Find the 4th derivative of y equals 1 over x squared. I want to do this one because obviously people still mess this one up. What don't you like about the way this is written? What should you write it as? Y equals what?
Negative.
X to negative.
Okay, now take it to the 4th derivative. Now, this is why I'm very particular when this was me rewriting y, this is me taking a derivative when I write y prime. So negative 2x to the negative 3. Take it again, positive 6x to the negative 4. Take it again, negative 24x to the negative 5. And then take it to the 4th. 120 x to the negative 6. But obviously, rewrite that in a better way for me. What would that be written as? Yeah. Oh. Hope you're being well today.
I still have this picture.
All right, go. Pause for waving at my son. Yes, he gave Carson a picture today.
Wait, how can you separate the 120 and X to 6? Is that alternate one?
No,
Why not?
the only thing that's going to a negative power is x, so that is what moves to the bottom. All right, now, why do we do this, Mrs. Why are we taking higher order derivatives? No, see, this is when I wish we still had a physics here at Metrolina.
Because then it all.
It's just different planes.
I wish we had thermo.
Oh, well, then this is going to be making some sense to you.
Yeah, only we had thermodynamics.
We are going to learn to find acceleration.
What?
Okay?
Really?
When Mr. Risley taught physics, this was a couple years ago. You can do physics, obviously, without all of Algebra 2. That's all you have to do. You don't have to do, but you could also do calculus-based physics, which is actually, surprisingly enough, much easier because Well, I'll show you with our example.
You can do derivatives.
It's like having
Exactly, you do derivatives. So you're like, oh, this is so much easier. Woo. All right.
And derivatives are easier than calculus.
So let me first, in physics, let me give you what's called a position function. This is a formula to find the position of an object at a certain point in time. So your position function is S of t, that's what they use in this book, equals negative 16t squared plus v naught, I'll explain what that is in a minute, t, plus h naught. Have you seen this before? Not yet?
Yes.
Okay,
No.
Who's seen that?
Matt.
Wait, so what's the V?
Okay, I'm going to tell you in a minute, okay? In your position function, the V naught, actually, it's called V naught, N-A-U-G-H-T. But what it means is it's the initial velocity of an object.
Ah.
So again, if I'm like throwing a football up into the air and watching it come down, what's the initial velocity of that object? The H naught is the initial height. This negative 16 actually refers to something that good old Isaac Newton found. But negative 16 refers to what? Anybody, you know what that one refers to?
I forgot it. That was the first.
There was a problem like this on the SAT.
Yes.
It was like a rocket ship thing.
Yes, which you could do in algebra, okay? But I could show you how to do it with calculus. Negative 16 refers to the force of gravity that's upon us in feet per second. So it actually is, and if we were doing this in meters, we would actually change that to negative 4.9, I believe.
Always negative 16.
So it's always negative 16. It's the force of gravity upon us.
Wait, why?
Yeah.
How do you do those problems?
Okay, we'll get to it. Okay, what is T referring to?
Time.
Time, okay? So time in seconds. So we're going to do an example right now. And I do want you to write this all out for me. Okay, it's a wordy example, but just write it out. A ball is thrown into the air from the top of a 160-foot cliff. The initial velocity of the ball is 48 feet per second.
I would have loved to know this for this.
I'm sorry. You can
Would
still,
have been very convenient.
you can still do it with algebra. We've done it in
I
algebra.
need a 5 cent in there, be like, oh, you missed this one right here, the one that we could have caught.
If you get a 570, I will be sad for you about that.
I got 570, then I'm like,
What is that value for velocity?
48 feet per second.
just kidding, I mean 11.
Okay, we are going to find height, velocity, and acceleration of the ball when t equals 3 seconds. Okay? And we'll explain this. So let me read this again to you for those who are still copying it down. A ball is thrown up into the air from the top of a 160-foot cliff. The initial velocity of the ball is 48 feet per second. The position function is, we're going to do that right now together. We're going to find the height, the velocity, and the acceleration of the ball after t. This is why calculus becomes so cool, okay? This is why, like, we can find the instantaneous rate of change. We can find your instantaneous velocity and acceleration at, like, of a rocket going into space after a certain amount of hours. You know, that's what's so amazing that we can do this now because of calculus. So we have this cliff. We're taking a ball, we're throwing it up into the air, and obviously it's going to fall, right? Okay, due to gravity. Yeah. All right, so let's first, though, write out a position function. So looking up here, our position function would be S of t equals negative 16t squared. That doesn't change. What am I going to put in here for V naught? 48, right? Isn't that what it said? Initial velocity, 48t. And then what would be the initial height? Where's my ball at? 160. Okay. So now I want us to find the actual height of that ball. What do I do?
Plug in 3.
After 3 seconds. So find the height after 3 seconds. So I want to know what the S of 3 is. God bless you. I'm going to tell you what it's going to be. 160. Well, that doesn't make sense, or does it? Why is it 160?
Because that's your height.
Exactly, because you threw it up. And let me show you with my animation here. 1, 2, 3. It's only 160 feet up.
That's sick.
Okay, does that make sense to you, right? It went 1, 2, 3. It met right there where it was at. All right.
You just said that because you just said how can you say that?
I'm asking you, why do I have 160 again when it was originally at 160? Okay. All right, now, are you ready for this? Velocity, which is the speed at which the object is traveling. Are you ready for what it is in calculus? It's the derivative, the first derivative.
You're lying.
You're lying.
So what's the first derivative of this position function right here? What would it be? Negative 32t plus 48. So if I want to know what the velocity was after 3 seconds,
Plug it in.
plug in the 3.
This literally, it was asked for velocity.
I'm sorry.
I could have just done this.
Oh, there's my husband. Okay, question. You get out negative 48 feet per second. Why is it negative?
Because it's going down.
Oh, so gravity is pushing upon us and it forces us to have a position of negative 48 feet per second. All right, are you ready for this one? Acceleration is defined to be the change in velocity, or the
1 over velocity.
the slope of the velocity, which means the second derivative.
No.
Your acceleration, your change in your velocity is just a second derivative. What's the second derivative of this? Negative 32. So after 3 seconds, isn't it still negative 32? Right? You can't plug it in. So it's negative 32 feet per second is what it's accelerating at. All right, now I'll give you the choice that I gave to the other class. I can do question number 43, which is the word problem, on your homework due Friday right now, which I did for the other class, or I could do some of the problems that you're needing help from the packet for the quiz tomorrow. That's what I have a feeling. Let's do it.
Quiz tomorrow, please.
We've already decided 43.
Andre Babby just
No, this is a good one. I kind of want to do it. It's fine. Yeah, I give you the answers. Give you the answer, Kitty. He's like, no. All right, if I don't get 100 tomorrow. All right, this is on, by the way, page 146. I'm going to show you the word problem, then we'll talk it through. This is actually quite a funny word problem. Let me explain it to you. A brick becomes dislodged from the top of the Empire State Building at a height of 1,250 feet and falls to the sidewalk below. They really do have funny ones, yeah. Is anybody on the sidewalk? Exactly. Write the position function of the brick. Write the velocity and acceleration functions. How long does it take the brick to hit the sidewalk? How fast is the brick traveling when it hits the sidewalk? So we're going to do this one together, okay? So I think you can do part A right now. Can you write a position function for this brick? What would be your position function? S sub t equals negative 16t squared, yes. And then what's the initial velocity if a brick is falling from the Empire State Building? What's the initial velocity it's being falling from?
Negative something.
From 0, yeah. Right? It didn't, I mean, somebody could have pushed it, but it fell. So it had a speed originally of nothing.
Like this, like they just chucked it down. Wouldn't have more velocity?
But no one, it didn't say that it was thrown.
But it's at that initial place, so it has-
Okay? So you don't have to put this 0t here, but I'm just putting it there for you. That's the initial speed. That's, when did you agree, the initial height? Because it said from a height of 1,250. Okay. So we did part A. Part B says, okay, find the velocity and the acceleration function. The velocity is first derivative. The acceleration is second derivative. So go ahead and find those for me real quick. Velocity,
Wait, what is,
Acceleration is
Easy.
so this one should be easy. This is just negative 32t. This one is negative 32 feet per second. All right, now part C, though, you have to think about, and that's why we're doing this together, ND, okay? And I'll read it again up for you. How long does it take the brick to hit the sidewalk? How long?
Sidewalk is 0 feet.
Okay, go with me, Andre. Listen to what my good buddy Andre is saying. Sidewalk is at a height of 0 or a position of 0. Would you agree? So what am I setting equal to 0?
Y,
Which one?
S,
Acceleration.
A or B? Or
A.
A, I'm going to set this equal to, this is my position. Okay? And I'm going to solve that equation for t. Negative 1250 equals negative 16t squared, divide by negative 16. I think it's like 78 or something. I can't remember. Do you have it? Yeah, you are going to square root it. And you're going to get up with plus or minus roughly 8.8. Why is it not minus? You can't have a negative time. We can't go backwards in time. Okay?
What are you, time machine?
Okay.
actually,
So, after 8 seconds, it has fallen and hit the sidewalk. Hopefully no one is dead, okay? After 8 seconds. So now we're going to answer part D. How fast is the brick traveling when it hits the sidewalk? What do I do there? No, stop. How fast? Fast is speed. Listen to what is velocity. How fast? What is my speed? How fast is the brick traveling when it hits the side? Did we find out when it hit the sidewalk?
At 8 points.
At 8.8. So where am I going to plug in 8.8? In the T for which one? The first one?
Velocity.
If we plug 8.8 in here, wouldn't I get 0?
Yes.
So I got to plug it in here because this is the velocity. How fast is it going? So part D, I want to find out what the S prime of 8.8 is. I want to find out how fast it was going at 8.8 seconds. And if you figure it out for me, I think it's like negative 200 and something if I'm right. I can't find it. Anybody have it? Oh, I have a calculator right here.
Awesome. How is there negative loss?
Well, that's,
8.8 times negative.
yeah.
No, but it's
Feet per second. What does that mean? Holy cow.
That means
It's going down.
That brick, if you were under that brick, it is hitting you at a rate of 280 feet per second.
you'd be dead.
It's gonna be touching your toes.
Yeah, I mean, this is why they talk about like the penny dropping from the Empire State Building and killing someone. I don't even know if that's true, but that definitely a brick. Don't want to know what brick is. Okay. All right. Actually, the penny was.
Air resistance.
Yeah.
Air resistance.
Air resistance.
That was actually so